We recently announced new capabilities related to named replicas in Azure SQL Database Hyperscale. Learn all about it in this episode of Data Exposed. Hi, I'm Anna Hoffman, and welcome to this episode of Data Exposed. Today, I'm joined by Davide Mauri, a program manager on the Azure SQL team. Davide, thanks so much for joining us today.
Hey, Anna, thank you for having me again.
Always a pleasure to have you on Data Exposed. And before we get into it, can you explain just to our viewers a little bit about what you do?
Oh, yeah, absolutely. As I have a lot to say about myself. No, just kidding. I have prepared a slide just to make sure that I remember everything. So I've been a MVP for 12 years, and now, after all that time spent on SQL Server, I'm actually part of the Azure SQL PM. And my job as Azure SQL PM is to make sure that we listen to customer, that we understand what the market is asking, that we came up with some interesting features to add to the product and make that happen. So pretty cool, pretty interesting for me. I'm also very active in the community, as you can see. So I have website, dev blogs, in several places. But most importantly, last year with you and many other, we wrote a book called Practical Azure SQL Database for Modern Developer, which tries to summarize everything a modern developer should know to take advantage of Azure SQL to create modern application, using microservices or not maybe, but in general using everything that Azure SQL offers, which is a lot. And no matter which language they are using, so Python, .NET, Java, everything, because Azure SQL can be used with everything and every operating system. So I was super happy and proud to have this book written, and I'm pretty sure the developer will enjoy it a lot. That's everything about myself.
Awesome. Well, thanks for coming on the show, Davide. We're excited to have you. And yeah, it's always nice to plug the book. There's no bias from us at all, but we'd love for you to check it out. But today, we're going to be talking about a really exciting topic related to hyperscale. And I think a lot of our viewers have kind of learned a little bit about hyperscale and understand it has support for limitless storage in theory. But today, I wanted to spend some time learning a little bit more about replicas and how they work in Azure SQL Hyperscale. So I was wondering if you could start there by talking to us about replicas.
Yeah, absolutely. So just let me do a step back and refresh our listener and watchers how hyperscale works. So basically, in hyperscale, we have completely restructured and re-architecture the storage system of SQL Server or Azure SQL, and we have now a primary compute node where actually you connect and run your query and send the read and write queries. And then all the data needed there or changed there is actually sent to page server. Now I'm explaining it is a high level. There are lot of technical details into that. I think Denzil already did some presentation here, but what you need to know is that data lands in page server and lives in this service, which is a set of distributed services that can elastically scale out, so we can easily add page server when more space is needed. And this page server, the beauty is that they are not files, they are servers, so they can be used by other compute nodes, for example, the secondary compute nodes. And that's what we have today, or we have been having so far. The secondary compute nodes that help the primary compute node to have a higher availability. Sometimes they can also help in read scale out option. But the idea is that a secondary compute node is something that can help hyperscale to do something more, be it a better SLA, be it a replica or replicating data in another region, be something else. So the whole idea of hyperscale replicas is that a replica is basically a compute node. It can be a primary when it serves read and write operation, or a secondary if it provides scale out, high availability, or geo-replication. And we have three types of replicas today. Before we had only one. We always keep Azure SQL Hyperscale improving. So we decided to split these replicas in three different types. High availability, which is the one that people and developers used so far. Named replicas, which I will be discussing today, and which is in private preview, and geo replicas, which again is something that Azure SQL add for other SKUs. We brought it also to Hyperscale. GeoReplica involves a physical copy of data, while, for example, high availability and named replica doesn't. But I will not be discussing georeplication today. Today I will be focusing on named replicas.
Awesome, cool. Let's dive into them. What can you tell us? Like, what's the difference between high availability and named replicas? And tell us more about name, because that seems to be pretty new.
Oh yeah. So I have availability replica. I said what has been always there. They are beautiful because they automatically allow you to fail over the primary and the secondary. It's super fast. The failover usually happens in a matter of seconds. I tested today, 12 seconds it took, so super fast.
Wow.
There are a few drawbacks of high availability replicas due to the technology we had to use to make it so fast. For example, they are not visible in the portal. You cannot go to the portal and see one of those replica. You cannot access them directly because they don't expose a connection string. You can access to them using an application intent option in your connection string when connecting to the primary. But if you have more than one, they will be accessed round robin. You cannot really choose where to go. So again, their main purpose is high availability. That then can also be used for something else, but high availability is really what they are good at. And for that reason, their service level objective is always in sync with the primary. So if your primary has 4 cores, all the replicas have also 4 cores. And in general, you can only, in quote only, have only 4 replicas, which usually for SLA, it's more than enough, because if you need 99.99% of availability, you can achieve that using only 2 additional secondary replicas. So if you need more, you can even increase the number of replicas or do the scale out read-only. But as you can see, they are very good for HA. They are decent for a simple read scale out. But many customers doesn't require a simple scale out option. They need something much more complex. So that's why we created the named replicas. So with named replicas, we basically allow you to have an independent compute node connected to the primary replica page servers. So we just spin up a new compute node, connect to the existing page server, and you have a database that you can access to in read-only, of course. This again means that it's super fast to be created. You can have up to 30 replicas because we are using different technologies exactly than high availability replicas. So you can really scale out immensely, I would say. And you can even have an independent service level objective. So let's say you have a 20 vCore primary, you can decide to have 30, 80 vCore replicas if you really need a huge amount of read power. Yeah, probably that's going to be unlikely, but for some customers that they want to do complex data science or analytical queries, that could happen. And the beauty of named replicas is that since they are really visible like a regular database, they also have a dedicated connection string, so you can connect to any of the named replicas you want. And they are manageable in the portal or via T-SQL or via AZCLI, PowerShell, or REST API like a regular database. So they really behave like a regular database, with the exception that they are immediately created by from the copy or a logical copy of the primary. Another very interesting thing is that they can have their own security configuration, which means that you can create a named replica and you can give me access, for example, to that named replica, but make sure that I cannot connect to the primary. So I have a isolated connection that can reach the data that you are actually changing on the primary, and that I can immediately see on my secondary, and I can do whatever query I want to do, especially with let's say you have 20 terabytes database and you want to do some super complex analytical query.
Right.
If I would run it on the primary, good luck to your primary to be able to serve some other workload, right? If I do it on the secondary, yeah, it's another compute node. So literally there is no overlaps or resource contention. And creation is very fast. Named replica can be created in 10, 12 seconds. So again, super fast. And yeah, it's very easy to create one, use it, and destroy it if it's not needed anymore.
Wow, this is pretty cool, Davide, and seems like some, like pretty big technical advances to kind of get to where we are. I mean, 30 replicas, create them in seconds. Like, what are some use cases you're seeing from customers or you envision for this sort of thing?
Yeah, so the most natural and probably the easiest to think about is the massive OLTP scale out. For example, when you have mobile application or gaming application running on a mobile, and you need to have a massive amount of querying capabilities because you need to update, player statistics, player position, everything. And of course, the amount of data that is read is immensely higher than the data that is written. So it's very common to have one database, the primary, that can just do writes, and all the reads are sent to the named replicas. Or the same approach could be with e-commerce or shopping cart management, or in general anything that needs a lot of reads compared to what is written. Again, for example, a website is another typical application of e-commerce, of course, and so on. But another use case, completely on the opposite side of the spectrum, is near real-time hybrid transactional analytical processing. Like, for example, you are ingesting data from IoT device, and you want to be able to run complex reporting on it, or update dashboards. And again, it's the beauty of named replicas is that you can have one primary ingesting the data and n secondaries allow anyone to query the data, be it via mobile application, be it via, for example, Power BI. And the secondary will not affect the performance of the primary, which will still be always able to ingest IoT data, or it could be maybe monitor instead of IoT, or analytics, for example, log application analytics, reporting, doing machine learning, scoring. So lot of scenarios are also able on that side of the world. Other few that comes to my mind, as I said before, isolated data access or data share. For example, I can take my entire database and give it to a data science, maybe it's another company, a data science department, and they can run any query without affecting the capability of my primary to run a workload. And in general, also, named replica are isolated even between each other. So even if you have 10 named replica use it for something else in your department, and then you want to give one named replica to another department, you can still do so, and making sure that none of the workload run on a replica will affect the workload run on another. So it's very, very nice to have this capability to have a huge scale out scenarios. And just to give you a couple of practical examples, for example, what we have, you can create what we call the workload dependent service objective. For example, let's say your primary replica is 8-week course. It's an e-commerce website. Maybe what you can do is create a couple of named replicas, each one of 16-week course, to allow the analyst and the market analyst to run any Power BI query they want in real time on the data coming in from your e-commerce. And maybe you also have a set of data scientists that they want to analyze basket analysis, correlation, whatever, and they need to access it via Apache Spark. And you can do that. You can create a named replica that will only serve workload coming from Apache Spark. So data scientists, analysts, users, all online at the same time without affecting performance of each other. Beautiful. And last one is what we call the workload dependent routing, which this is probably easier. Let's say you have a website, or better, an API. And this API is served also to publish some data to a website that shows, using Vue or React or any of those nice framework. And but many of your users are actually mobile users, and you want to make sure that mobile users do not affect the performance of web user, and vice versa. So you can create 4 named replicas to serve the request coming from the mobile app, and 2 named replicas to serve the request coming from the web apps. Beautiful, very easy, quick, and you just select how named replicas create it, and it's done. So very nice.
That's really cool. And one thing about all this is, I think you can manage the security for each of these. So maybe does that help in giving like granular access permissions to different of these replicas?
Oh yeah, absolutely. I can choose again to say maybe I don't want the Power BI users to be able to see some data that instead should be visible by the Apache users, or for the mobile and web apps user example I was doing before. So I can really decide also how granular I want my data to be shared. So that enables a lot of very interesting scenarios. I'm pretty sure some customer already started asking us to implement, and many more will probably take advantage of.
Awesome, cool. Well, hey, this has been super cool. I think what would be awesome is if you have something, we'd love to see this in action.
So I created a sample application, which is actually also available on GitHub, where I created a simulator of a shopping cart controller, just to simulate an e-commerce, very, very basic. And this is deployed as a application running on Azure. And I also created, and this again, everything is available in GitHub, also a test application that uses Locust to simulate some workload, right? So here I'm simulating people adding data to the shopping cart, people getting data from the shopping cart, and someone doing some more complex operation that takes, as you can see, quite a lot of time, right? Now, if I run all of these in just one node, and let me show you here. Here I created, for example, here we go. I created my solution so that the API knows what are the named replicas available. And right now I'm not using any named replica. So all the workload is sent to the primary compute node. So if I run this very quickly and easily, create a new test, 100 users, you will see that the fact that someone is running something very complex is also affecting the ability of my users to put data in the shopping cart, because the average time that each call to the shopping cart to add some product is taking almost half a second. And we know that if a page takes too much to load or a API too much to respond, people will go away because they are used to have a very responsive time. So let's stop this just to make it easier to see. And let me make sure that my APIs now knows, and of course I coded this logic in my application, now knows that they can use a couple of named replicas. And I created my named replicas in a very easy way. I just did that. Alter database, so very easy, and this take again a couple of seconds. So I did that. I now in my application I have a list of servers I can also use to send a read-only workload, and now I just have to run my test again, and you will see that the average time is way lower than before, like 30 milliseconds instead of 400.
Wow.
So this means that all my read workload is now handled by another set of servers, and the write workload is now free to run as fast as possible without being interfered by this very complex query is taking on average 3 seconds to be executed and takes a lot of CPU time. Now, why I told you before that I put in my application the logic to basically decide where to send my my query, because this is exactly my recommendation to developers. They should start to architect application so that the application can decide which replica to use. If I'm sending a write request, I should, of course, send it to the primary replica. But maybe I'm running a reporting request or analytical request or something else. And then if I know which kind of resource I need in terms of CPU, how much resource I need to consume, I can easily send it to the most correct named replica, as I'm doing right now. So if I want to improve this solution, for example, I could even decide to send only this query, which is super complex, to a dedicated named replica, maybe with twice the number of vcores that the other has. So it will be finished as fast as possible. So I think this is something that can really change the way, and should really change the way developer architect modern application, taking into advantage the ability to quickly create copies of data, destroy it if not needed. And of course, this can be all dynamic. Maybe during the peak hours, I create more replica. During low usage hours, I just send everything to the primary because it's just a bunch of queries per hour, maybe.
Thanks, Davide. That's been a really cool demo. And what I liked about it is like you showed us a couple different use cases for how you might use named replicas. So I'm seeing a lot of opportunities, and I think our viewers probably are as well. As we start to kind of close out the episode, can you give us or viewers like some tips and tricks or advice, or is there anything else you want them to know?
Yeah, absolutely. So first of all, let's make sure that everyone knows that this is a public preview. So it feels like GA. It has all the feature of GA, and pricing is also like GA, but it's still in preview, which means that we are, first of all, we are not expecting any issue. But if you encounter any, just send me an email with the feedback or whatever problem we had, and we'll be super happy to help. Second is that pricing is also amazing, and this is another thing to keep in mind when architecting solution. Why scaling out is better than scaling up? Because named replicas are priced with automatic Azure hybrid benefit applied, which means roughly 30% less than a usual database cost. So this means that if I can architect my solution to scale out instead of scaling up, I can easily, spare 30% of the cost of running my entire solution, which is quite an important part of the total cost. So yeah, that's something that people should keep in mind. Absolutely.
Awesome. Well, thanks so much, Davide, for coming on the show. This has been really useful. I've learned a lot. I know our viewers have learned a lot. We're going to put some links in the description for folks to go deeper. So we encourage our viewers to check this out. To our viewers, if you like this episode, go ahead, give it a like, subscribe to our channel, and we hope to see you next time on Data Exposed.
Thank you. Bye.